Hello, Algebra 2 class, Mrs. Levenseller here, and we're going to cover two learning targets from your first unit. Learning target 1b, I can solve a linear inequality in one variable, and learning target 1c, I can describe the solution to an inequality. So these are connected because first we have to solve, and then we have to figure out what the heck did we just find once we solved it, all right? Your steps for solving are the same as they are for solving an equation. But now we have an inequality sign, right? This guy right here. So let's briefly review what those inequality signs are, just to help you out. So we have 4, right? We have a greater than sign. We have a less than sign. I always think less than points to the left when you're making a math sentence. We're no longer really thinking about the two numbers because we're starting to throw variables in here. So the idea of the alligator eating the bigger number kind of goes out the window when we talk about variables, okay? So we want to remember that if a sign, the symbol points to the right, it's saying greater than, and if it points to the left, it's saying less than. Once we add the line underneath, that means equal to. So in this case, it could be greater than or equal to the value that we get. And in this case, it could be less than or equal to. All right, and we'll come back in a second and talk about how to express this on a number line or in some notation. But let's first solve this inequality. So our first example here, if you have your notebook, you can highlight this example. -3 minus 6 times 4x plus 6 is greater than -111. All right, quite a doozy here. This is a multi-step equation. So remember your steps to solving. The first thing we want to do is to distribute if necessary. Well, I see distribution right here. So -6 times 4x would be -24x. The negative comes with it. And -3 is just hanging out here in the front. We're not going to touch that yet. And then -6 times 6 is -36. I'm going to finish the rest of my sentence and bring down the -3, okay? Next step, we want to look for anything we can combine on the same side of the inequality sign. So on the left here, I see a constant of -3 and a constant of -36. Let's clean that up and combine those. Well, -36 and -3 together make -39. And then -24x, we're just going to bring down because it can't be combined with anything else. And that is greater than -111. All right. The next thing I'm going to do is add 39 to both sides because I want to isolate this variable x, right? So I need to add and subtract values away from the variable. So -24x is greater than, let's see, what do we get from -11 plus 39 is -72. Our answer is going to be negative because the larger number was negative. And then divide by -24 and x, and then on the right hand side, -72 divided by -24 is going to give me +3. And before I write that inequality sign, I want us to remember one key rule. When we multiply or divide by a negative, we need to switch the inequality sign. All right. And that's because a negative sign really means opposite, okay? So when you're making something opposite, we have to make the whole sentence opposite. We have to change all of its parts. If we left it the same, then when we tried to check our answer, we would find it wouldn't work, okay? Technically, you do this with an equal sign too. Just an equal sign looks the same no matter which way you write it, right? So, and it's, I think, nicely designed that way. So we know it's the same no matter what. It goes both directions. But here, instead of saying x is greater than 3, we're actually going to say x is less than 3, okay? So let's talk about, the second part of this is talking about what that solution actually means, x less than 3. That doesn't mean our answer is 3, okay? So inequalities actually have an infinite amount of solutions or an infinite amount of answers to their problem. This is telling me that every number less than 3 can be a solution to this inequality. Well, I guess I shouldn't say can be, it is a solution to this inequality. And one of the ways we can represent that is on a number line. So let's get out a little number line here. This doesn't have to be overly fancy when you're drawing them. I will put a couple numbers on. I'm going to put 0 on here and go up to 3, the value that I need, okay? If your number is that you got in your answer is not close to 0, you don't have to put 0 on your number line, okay? Just make sure that you have the value you need, and then a few values higher and a few values lower than it. So here's my number line. When we express a solution on a number line, well, if it's a less than or a greater than, we're going to use an open circle, and that's because we're not including or excluding the value. Okay, we are excluding the value of the number 3. If we have the equal to sign as well, then we're going to use a closed circle because we are including the value as part of our solution. Okay, so when we write this, we're representing all the answers, all the possible answers we could have. So x is less than 3. Then I'm going to go to 3 and I'm going to put a circle around it, but I'm not going to fill it in because 3 is not part of the solution. Only numbers that are less than 3 are part of the solution. So I'm going to shade all of the numbers less than 3, which would be everything to the left of that. And when you think about that, it's not just saying that 0, 1, and 2 are solutions. It's saying -1 is a solution, negative 2,783 would be a solution, negative or positive 2.9 would be a solution, right? Any single number that's less than 3 is a solution to this inequality, okay? And there's actually 2 ways that we can represent this without a number line. So let's take a look at that. Let me get rid of this really quickly. Oops. So if we have all the numbers less than 3, we can write that in set notation, all the values in the set of x, such that x is less than 3, right? So this means the set of, just kidding. This symbol means the set of, and this means such that. And here we have all real numbers, x. So x is representing all the real numbers, and we're saying that in this solution, the x values have to be less than 3. Those are the solutions to this problem. You also might have seen, I'm going to bring our number line back for a second, you might have seen interval notation. So that would be described on our number line, or that would be used to describe our number line. Using infinity and then parentheses or brackets. So if we have everything less than 3 on our number line, that would mean all of the numbers between negative infinity and 3, right? Positive infinity being at the other end of the number line. So when I want to express the interval, I would say we can use anything from negative infinity up to 3. And I'm going to close this with just a parenthesis because this is an open circle, okay? Meaning I'm going up to 3, but I'm not including it. And the same with infinity, you can never include infinity. If this were, for example, the expression x is less than or equal to 3, if that were our solution, and 3 was filled in, then we would have everything from negative infinity, still not including infinity, up to 3 with a hard bracket, because 3 is part of our solution, okay? So the hard bracket corresponds to a closed circle. A soft bracket, we call it, or a parenthesis, corresponds with an open circle. So keep that in mind when you're trying to express